All right, good afternoon, everyone. Hopefully we got loaded up with a little bit of sugar and caffeine at the break. I'm going to talk about the ID token authentication method in HTCondor. So assuming it lets me advance the slides. Okay. So in this talk, I'm first going to talk about what is the ID token authentication method and some motivation for it. I'm then going to give basic concepts and usage scenarios about it. So, why should you care? How would you set it up? Under what situations would you use it? And then we're going to wrap up the talk with some Mountain Dew advanced topics for you Mountain Dew drinkers, or as Marone always says, the Mountain Dew and non-showering crowd, which I am proudly a member of, by the way. Okay, introduction and motivation. So why do we need authentication, strong authentication methods in the HTCondor software suite? Well, with HTCondor, if you have a pool, you have some major components. You have a central manager that's running a collector. You have one or more worker nodes or execution points that are running start these. And typically these are accessed by an access point, which is running a SCED where jobs would be placed. Let's see if I can switch to the laser pointer. There we go. All right. So the HTCondor services, AKA these daemons that are running to implement the Condor service, are authenticating to remote HTCondor services. So this access point is running a SCED. It needs to talk to the collector. Similarly, the start on the execution point needs to advertise ads to the collector. And the idea is you only want trusted nodes admitted into this pool, okay? Because for instance, let's say a bad actor came along, fired up a start on a machine, and just added it into your Condor. You wouldn't want that to happen because now this bad actor might get jobs matched to this execution point and get access to job data, input files, output files for the job. Maybe they could modify the output files and send them back so the researcher doesn't even know they're getting false data. Likewise, you don't want to allow untrusted access points to connect to your pool, because then they could submit jobs that does Lord only knows what, Bitcoin mining or what have you, right? Or worse. So you want to make sure all the services in your pool are authenticated and can be trusted. Likewise, there's users that are placing jobs, submitting jobs to the access point using things like Condor Submit. You want to authenticate who those people are as well. One reason we want to do this is HTCondor, we want to say that nobody can remove someone else's job. So if Todd submits a job, well, then Greg shouldn't be able to remove it just because he doesn't like me, right? So Greg is like, I'm going to remove your jobs all day. But yeah, so this is why authentication is also needed for users authenticating. And finally, we have special users that we call administrators that have a little crown on their head. So like, in the CHTC, Aaron Moat is one of our administrators, and he walks around with a crown on his head because he's special. And the administrators, we need to be able to authenticate. So only the commands that administrators should be allowed to do are available. So administrators can do things like drain nodes or change the priority of different users, right? If there wasn't strong authentication across the network, then I could change my own priority and I could be the top dog in the pool instead of requiring someone with a crown on their head to bless that decision. So after authentication comes authorization. So an authentication method results in an identity. At the end of authentication, HTCondor knows that the person on the other end of the wire is Todd or is Greg. Authorization is what is that user allowed to do? So you could say, well, anybody who authenticates as user root or user condor is allowed to do administrator commands, like change user priorities. Users that just want to submit jobs, like Alice and Bob, should have write authentication. And anything that authenticates as Condor here in the config file, I'm saying is part of the actual trusted Condor system, is another daemon, okay? So authorizations just go in the Condor config file. So ID tokens is yet another authentication method. And HTCondor already had a whole bunch of them. So why did we feel for HTCondor 9.0 that we needed to add yet another authentication method? And the answer is all these different authentication methods have pros and cons. And they all had their shortcomings and complications because nothing in life is free. So for instance, one authentication method that we've had forever in HTCondor is FS, the file system. And the idea is you're on a machine, maybe you run Condor submit. Condor submit goes to the SCED and says, hey, I'm Todd Tannenbaum, I'd like to submit a job. And with FS authentication, the SCED would go back to the Condor submit and say, okay, prove it. Make a file in /temp. And Condor submit will make a file as me in /temp, and then the SCED stats the file and sees who owns that file. Oh, Todd Tannenbaum actually owns the file. I'll trust that you really are Todd Tannenbaum. So file system authentication is great. Nothing needs to be pre-configured. It just works. It works reliably, but it doesn't work over the network, right? So it's kind of useless if you're trying to authenticate from one server to another server. We have pool password, and this works great, but it's only for Condor daemon to Condor daemon. It doesn't work for tools or end users, so it wouldn't work with Condor submit. And we have a whole bunch of other ones: SSL, GSI, Kerberos, Munge, tokens. These all have nice capabilities, but they typically require additional setup work or installations from third parties for various tools and services. So for instance, SSL, well, you probably need to make a host certificate, you need a CA certificate, yada, yada, yada. Munge, you need to run a daemon on your machine that comes from the Munge project, you need to configure it, so on and so forth. So this is great if your site is already using these. Now, you heard Derek tokens talk earlier. Tokens are great. ID tokens are a little different in that, one, they're simpler than tokens. And they're simpler because they kind of do less than tokens. Tokens can be issued by a third party and then consumed by HTCondor. So like the LIGO experiment could issue tokens in order to be able to submit a job somewhere, and then Condor consumes that. ID tokens, as we'll learn, are both produced by Condor and consumed by Condor. So they're a little simpler. And ID tokens are identity-based as opposed to capability-based, which has pros and cons as well. So we'll talk about that. So we added ID tokens as an authentication method because we wanted a solution that's self-contained, works over the network, and works for both daemons or users that are using tools. And this was the technology that enabled us in HTCondor 9 to have it secure by default upon installation, not based on hosts, but actual credentials. So basic concepts and usage. So right over where I want to be. An ID token contains several fields. The first of which is an identity. So in this little, I'm running Condor token list here, which is showing an ID token, all the ID tokens installed. And this attribute here is the identity. So this token says, I am Alice at some pool. That's why we call them ID tokens. They have an identity. They also have a bunch of other fields like who issued the token, a unique ID for the token, the date the token was issued, maybe an expiration date. All of these, and maybe some authorization limits. All of these attributes are then signed with a digital signature. And in order to sign it with a digital signature, that uses a secret signing key that's stored on the server where an HTCondor is running. and the digital signature proves authenticity. ID token is serialized out as a string, and then you typically store it in a file. And an ID token is always presented by a client to a server. So it's not mutual authentication, right? It's you're a client, maybe you're running a tool, you present a token to a server, and now the server knows who you are. All right, so let's have some concrete examples. We're going to do one example for administrators. We're going to do a different example that might be applicable for end users. So the first example for administrators is we're going to use ID tokens to secure a site installation of a Condor pool. And in fact, this basically is what the Get HTCondor setup tool does. It sets it up for you. You don't have to concentrate too hard on the details here, because if you run Get HTCondor, it configures it exactly the way I'm going to describe it. So the key to a secure Condor pool is to only allow trusted, authenticated, and authorized StartDs and SCEDDs to advertise into the collector on your central manager. So on the configuration on my central manager, I say allow daemon is only this user Condor at my organization. Okay. So how do I do this? Step one is on the central manager, I'll create a signing key file. And this is, I can do this by running the Condor store cred command, add -c, and then at that point I give it a password, and it'll hash that password into a signing key and store it. Or the collector, when it starts up, it'll generate a random signing key and just drop it into the file. So you probably already have one sitting there. And it'll be stored in its set Condor passwords.d in the file pool. So step two is I'm going to create an ID token file with the identity Condor on the central manager. So to do that, I would, as the administrator, I do Condor token create minus identity flag, and I'm going to say that the identity for this token is Condor at cm.myorganization, centralmanager.myorganization. Next thing, I'm going to copy this ID token file I just created to each trusted server in the pool that I want to join. I'm going to just copy it on each server into its set Condor tokens.b. So this is the diagram I now have. So at this point, when this SCEDD wants to join the pool, it'll do so using its token. So its ID token. It'll be securely authenticated and authorized, so we can trust it. If Joe Bad Guy tries to set up an access point, Joe Bad Guy server will not have a token on it, and so it won't be able to join the pool, because the only daemons that are allowed to join are ones that can prove their Condor at my central manager. Ditto for the execution points. So what about securing administrator commands? So we want an administrator, one of these special people with a crown on their head, to be able to log into the central manager, maybe sudo to root, and be able to do things like turn Condor on or off on any node in the pool, or drain any execution point, or run Condor user prio. How do we get that working? So in the diagram we have now, it won't work. So if I go into the central manager and I say Condor drain this worker node, maybe I'll use this token to try to prove who I am to the worker node. But the worker node has no signing key installed on it to verify this token, right? Because remember, tokens are always client to server. So what we can do is take this signing key from the central manager and copy it out to the trusted nodes in our pool, readable only by root, readable, writable only by root. And now the administrator commands would work from the central manager or any other node in the pool. So if I sudo to root and do Condor drain to a given execution point, this token will be picked up. It'll be presented to the worker node. The worker node can verify it using the secret key, and everything works. And this diagram right here depicts exactly how a pool is configured after using the Get HTCondor tool with HTCondor version 9.0. If you want to get into the nitty gritty, like exactly what goes into the configuration file to make this work, I suggest you do condor config val and then look at the meta knob, use security : get HTCondor tokens. And if you enter that command, it'll spit out the configuration pieces used to make this work. Or just install your pool using get HTCondor, and then this is what you get out of the box. So example 2, let's say you're an end user, so you don't have a little crown on your head. You're just you're a regular user trying to submit jobs. So Bob's a normal user, no root access. Bob can SSH into an access point and submit jobs, no problem. But Bob wants to submit over the network from his laptop. So step 1, Bob SSHs into his access point. He can't run condor token create here, like we did in the previous example, because condor token create requires root access. It needs to be able to read that signing key, because condor token create can create a token with any identity. But as a regular user, Bob can run condor token fetch. What condor token fetch does is it authenticates to a condor daemon by default the SCED using any authentication method that succeeds. In Bob's case, it'll be FS or file system because he's on the same machine. So the SCED knows it's Bob. And then the SCED will create a token and sign it and give it back to Bob. And the identity will be your Bob, right? So Bob runs condor token fetch, copies the output from condor token fetch to his laptop and stores it in his home directory in a home directory.condortokens.d. And at this point, Bob can now run condor submit on his laptop, and submit will present that token to the remote SCED, and voila, he can do remote submits. So a summary of the commands we've looked at so far: condor store cred -add, create a signing key. The collector has one by default. Condor token create. If you're root, you can create a token with any identity in it you wish. You give a bunch of command line parameters to change various attributes like lifetime or attenuation. So you can limit what this token can do, or an expiration date. Condor token fetch. This is used by regular users. It's basically you authenticate with a daemon and create an ID token on behalf of the user that ran condor token fetch. And condor token list, which is display all the tokens visible in your path and show what they are. We also talked about a bunch of default path names. This is where you put your signing keys. This is the directory where the condor daemons and the root user will look for tokens. And then this is the directory where regular users, people running without root power, will look for tokens. And of course, it's Condor, so there's configuration knobs to change any of these paths. So some advanced topics. What I have, like 5 minutes? So these are some questions that I've seen in the Condor users email list over time. How does a client securely present an ID token to a remote server? So, it's kind of the classic problem of I want to show you my token so you can verify it, but I don't trust you yet. So I don't want to give my token away to a bad guy in case I'm talking to a bad guy. And the short answer is, remember I said the token has a bunch of properties and then a digital signature. And what the client does is it just sends the properties over. It does not send the digital signature over, okay? The server, meanwhile, it knows which signing key would have been used for the digital signature, so it can just recreate the digital signature. It's got all the attributes from the client. It basically appends to it the secret signing key, does a hash, and now it has the digital signature, right? So now both sides have the digital signature, and they can use that as the basis of a secure channel using AKEP2 if you really have a lot of Mountain Dew. What about token revocation? Well, you can just remove the authorization for the identity. So let's say Todd is, I'm doing remote submits from my laptop. I forget my laptop at the airport. my access point administrator could just say, move me from allow right to deny right. And now Todd is not authorized to place jobs anymore. There is also in the config file, there's a class add constraint expression you can put in to refuse tokens based on any attribute in the token, such as identity or date range when the tokens were issued, or an individual token by its serial number. And there's examples in the manual for how to do this. I put the URL in the manual to these examples right here. You can also remove the signing key file that was used to sign tokens, and that effectively revokes all of the tokens that signing key signed. How does a client decide which token to use? They're scanned in lexical order in the directory. And the first token that was issued from the same server trust domain and signed by a key file still present on the server is selected. Another question is ID tokens. You know, they follow the JSON Web Token Standard, or JWT. Why do I care was a question. Well, one answer is you can use Derek Weitzel's awesome website to decode that token because it's cool. Another answer, though, is it's a standard. This is a security library that the HTCondor development team didn't have to write, and it's good if we, you know, are using what widely adopted and looked at security libraries. The other answer is if you're using the Python bindings that you heard about from Jason. You're using the Python bindings to interact with HTCondor. Now you have your pick of many different Python libraries to interact with standard JWT tokens. You want to look at these tokens and look at their properties. You have plenty of libraries to pick from. Is there an alternative to users doing SCP or copy and pasting of tokens? Right, in this example, Bob did a Condor token fetch, and then he cut and pasted his token back to his laptop or whatever. And the answer to that was alluded to in Brian Bachman's talk from last year's Condor Week. And basically in last year's presentation, Brian talked about Condor token request. And there was a gotcha there that the client needs to trust the server. And basically when you're requesting a token, this required some other network authentication method, typically SSL. And he said, look forward to new tricks upcoming in Condor version 9.x. And in fact, Brian will be talking about some of those new tricks, I believe, tomorrow in his tofu talk. That's tomorrow morning. Don't miss it. And that is my presentation.